Good morning to one and all. I welcome you all for the GATE recording class. Today we are going to see about network analysis. I am from S.A.E. Engineering College, working as assistant professor. My name is Venkat. I am working in EC department. Let us go to the session now. We are going for the network and signal and system. In this, we are going to see the topic Thevinin'S theorem. What is Thevinin'S theorem? Before going to the Thevinin'S theorem, why we have to go to the Thevinin'S theorem? The Thevinin'S theorem, which is useful to analyze the circuit while having a more number of components and sources which can be converted into a simple circuit. So it is not only used for the circuit analysis, we are going to implement in electronic circuits also. When the circuit design is going to be a larger one and complex one, we have to reduce to a simple circuit. For that case, we are going to apply Thevinin'S theorem. What is Thevinin'S theorem? A Thevinin'S theorem states that a linear bilateral network which has any number of sources and components can be converted into a single voltage source and a series resistor. Theorem states that in a linear bilateral network which consists of any number of sources can be converted into a single voltage source and a series resistance. The single voltage source is called as a Thevenin voltage and single resistance is called as a Thevenin resistance or look back resistance. So it is in a two-port network which has any number of components will be inside the linear network which has connected to the load resistance RL in a AB network. So that can be converted into a VTH and RTH. Then again we have to replace by its equivalent circuit to find the load current. So I am going to have a VTH, RTH and RL. So I can find the current is equal to V is equal to V by RTH plus RL. This is the formula for finding the current, VTH divided by RTH plus RL. Now, how to determine the voltage source and the current source resistance of a Thevinin'S theorem we have to see. First step, we have to remove the load resistance from the circuit. So we have to remove which is our destination resistance. We have to see that resistance is going to act as a load resistance that has to be removed from the circuit. That is going to be our first step. Next step, we have to determine or calculate VTH. So the VTH should be calculated in open circuit voltage, that is voltage across where we are removing the load resistance, that is from A to B where we are removing, there we have to determine the open circuit voltage. Then next thing is RTH. So how to determine the RTH? So first step, what we have to do, we have to kill all the voltage source and current source. What do you mean by killing? The current source has to be removed from the circuit, that is open circuited, and voltage source should be, it will be short circuited. This is a very important thing. Another case, if they given internal resistance for the circuit, then we have to replace the internal resistance in terms of the current source or voltage source. It's a very important criteria we have to consider while we are solving the problem. Next, let us take a gate problem. I am going to consider a circuit which consists of a voltage source and a current source. So, what they asked you to determine the 1 ohm resistance, determine the current through 1 ohm resistance. So, first step we have to remember that we have to remove the 1 ohm resistance. We have to remove the 1 ohm resistance. So, after removing 1 ohm resistance from the circuit, we have to find the VTH first step. So how to determine the VTH? The voltage across A and B, that is across the point A and B, we have to do it. Okay. So let us take, we have to determine the VTH. No? So for that, what I am going to do, I am going to draw a line from A to B. So we have to find out the voltage across this terminal. What are the components is coming across it? We have to see it. We are having only the 5 ohm resistance, that's all. So I have to find the current through 5 ohm resistor alone. It's enough. But since we have 2 loops, we have to determine the current from first loop and second loop. The first loop current I am going to name it as I1, second one as I2. So if I want to find out I2, I have to determine I1 because it has an effect on the resistance, because any number of sources is there, there will be effect on each number of sources. So what I have to do, I have to find out I1 and I2. So it's a very simple circuit. In the first loop, there is a current source given which is rising, that is going to be I1 is equal to 2 amps. So we need not to find out the loop at all because it's a very easy task. But in the second one, we can find it. That is going to be, we have to determine. Okay. So I am going to find the I1 and I2. Okay. Next step, what I am going to write the equation here. What I am going to do, the marking here as, I am going to mark here as I1 and I2. So what I am going to do, I am going to mark here, that is I1 over here. The current is flowing like this, so I2. So I have already found that I1 is equal to 2 amps. So I am going to go for the loop over here. 10 is equal to, there is a drop, so I am bringing all the voltage rise over one side and drop in the another side. I am going to write it as 10 into, it is entering and leaving here, so I am going to put it as I2 minus I1, then again there plus 5 I2. So I got the 2 equation now. There, if I want to simplify, I can write it as 10 is equal to minus 10 I1 plus 15 I2. So I got the equation. I know the value for I1. There I am going to substitute I1. I can find the I2 value. Now let us go for the equation. So I said no already. I is equal to, already they given us I is equal to, I is equal to 2 amps. Then I already said about the equation. Now we have formed the equation. So I wrote there here as 10 is equal to, I wrote no. See there is a change, nothing wrong in it. So it's also correct. Minus I1 plus 15 I2. So they are substituted here 2, no? After simplifying, we are getting as I2 is equal to 2 amps. So now I have determined the current I2. Already I find the I1. From the equation itself directly, we should not go for the loop equation, and we should not waste the time, because since we have a shorter time in each solving problem section in the guide question paper, so we have to manage our time. So that what are the shortcut methods we have to follow? We have to follow there. Now I am going to take it as I2 there. So now I am going to determine the VTH. How we are going to determine the VTH now here? So we have already found there as we have found that 2 amps current is flowing here. Okay. Now I am going to write VTH is equal to 5 into 2. Why I put 2 here? Because what is the current entering in this resistance is 2 amps. The resistance name is 5 ohms. So the 5 into 2. That is, we know the Ohm's law formula. V is equal to IR. So I am going to apply simple formula. So I have got the VTH. VTH is equal to 10 volt. Okay, finished. Next step, what we have to do? We have to find out the RTH. So for the RTH, what we have to do? I said we have to kill all the sources in the circuit. So how I can kill the circuit? That is, if it is in a voltage source, I should do it as a short circuit. If it is in a current source, it should be open. Still more, I said that if it has an internal resistance, we have to replace the source by its internal resistance. Okay, now what I am going to do, I am going to find out. So what is the simple technique we have to adapt, we have to see there. Okay, so here I have removed the current source which is left here. The voltage source is short circuited, current is open circuited. Now you leave off this part. Only I am having two resistance across the circuit. Now if you see the two resistance, how they are looking, whether it is a series or a parallel, let us see it. Okay, you just apply the current. What happens? The current is splitting into two. So that says the current splitting means it is a parallel circuit. So apply the parallel, that is R1 into R2 divided by R1 plus R2. So I applied, I got the 3.3. Another simple technique I am going to say, if you are going to parallel to resistance, that is 10 and 5, the answer should be less than 5. So which is the least resistance, that resistance, the equivalent resistance should be less than the least. So these are the shortest technique you have to remember while you are solving the problems. Okay, so I have got a 3.3 ohms. Okay, then next. So I am going to draw the equivalent circuit. Now how to draw the equivalent circuit? I have to take a VTH source. Okay, I should take a VTH source. After that, what I have to do? VTH and RTH should be connected. VTH, RTH and connected in series, and next step what you have to do, you have to reconnect the load. What is the load we have removed here, that has to be connected. So I have connected the load resistance. So what I am having, VTH is equal to 10 volt and equivalent resistance is 3.3 and 1 ohm resistance is removed from the circuit there. I have reconnected now. So I am going to apply in the formula. IL is equal to VTH divided by RTH plus RL. So I have substituted all the values. 10 divided by 1 plus 3.33. So I am getting the value as 2.309. So this is a simple technique to solve the problems. I consider two sources over here. One is current source and a voltage source. Let us go for the different circuit by solving another problem. Okay. So I am going to take another problem. So what are the techniques we have to follow? We will remember first, then we will go by step. So first step, what you have to do? What is a load resistance? That you have to identify. They have said as 6 ohm. So 6 ohms is going to be in the middle. So I am going to remove it. I am going to have A and B. Name it as A and B so that we can remove the resistance from the circuit. This is the first step we have to follow. So first step, I have removed the resistance there and name it as A and B. Next step, what I have to do? I have to find the VTH. So for that VTH, what you are going to do? You are going to find the voltage across A and B. So you are going to find the voltage across A and B. So for that, what are the resistance comes under this? You have to see there is two resistance are coming there. Okay, so I am having two resistance. So I have to find the voltage across. So they given only the resistance. So if they given a resistance, how can you convert into voltage? Means I should find the current through that component. So if I find a current, then V is equal to IR. So already R is there, I have to find the I for it. So then I can find the voltage across the resistance. Okay, so erasing this part. Okay, now what I should do? I have to draw the line across it. So I have two loops over there which is not connected to each other. They are separated. We should not apply the loops over there. So I am going to draw like this. And I am going to draw. Why we should not go by the cyclic and all. It is not important at all. Left your wish, you can apply any direction in the current loop. Only the change will be occur. There is negative sign will be there if you applying in different direction. So the current is entering and leaving here. Here also it is entering and leaving. I am going to name it as I1 current and here I2 current. So I am going to write the VTH equation. So VTH is equal to 8 plus 8 into I1 then while I am coming in this direction, I am encountering minus sign over here. So minus 8 into I2. That's all. So now I have to determine I1 and I2. Let us go and find the I1 and I2. So I am going to find the I1 and I2. So this is the step we are going to find the VTH. Now next step, so how to find the VTH? So I said there the equation I1 I have to find out here. So how can I find the I1? I1 is equal to, so this is a single loop, one voltage source is there, resistance is there. How they are connected, we have to see there. Whether it is in a series or a parallel, you have to see there. So I am applying the loop over here, the current is not splitting there, so they are in series. So I can write as 40 divided by 4 plus 8, you determine the current. Okay, now see here also, see there, the resistance are in series. So no current is splitting here. So I can write as I2 is equal to 50 divided by 4 plus 8. So 60 divided by 4 plus 8. What is the voltage source here? 60. 60 divided by 4 plus 8. So you just apply in the calculator. You will be getting the current as, how much we are getting? 4.127, and in this case 5 amps. Now the VTH equation we have already written there, 8I1 minus 8I2. You just substitute the value for this both, you will be getting 6.67 volt. Okay, next. Then we have to find out the RTH. How we are going to determine the RTH? They given there. What you have to do? You have to kill the source. That is, the voltage circuit should be short circuited. So what I am going to do? I am going to short circuit here. What is the source there? I am going to have as short circuit the voltage source. I am having a 4 and 8. And A point and B point, again 8 ohm and 4 ohm resistance. So how they are, you just see, apply the current here, what the current is doing, you just check it, whether it is series or parallel. If it is in a series, the current should be same. If it is in a parallel, the current has to be split. So here the current is splitting. So what I am going to do, the 4 is parallel with 8. Here also 4 is parallel with 8. So I have taken a 4 parallel with 8, 4 parallel with 8. How we are going to determine? 4 into 8 divided by 4 plus 8 plus 4 into 8 divided by 4 plus 8. You are going to get it as 5.33. Okay, so you got the resistance value. Now next step, what you have to do, you have to draw the equivalent circuit. How you have to draw the equivalent circuit? You have to draw the Thevenin equivalent circuit, that is going to be VTH series with RTH and load resistance RL, which is going to be 6 ohms, and value is 5.33, and this value is going to be 6.67. So they are getting us negative value. What I have to do it? I have to put a minus sign and plus sign, that's all. Don't change the direction of the current, because it's a very much important while you are considering the direction of the current. Now you will be getting the voltage current in a negative direction. Don't bother about it. It's just a direction which indicate the negative sign. Okay, this also maybe option may be given like this also, 5.89 minus 5.989. You will be confused, so you have to be very careful in the sign also, because the gate question is going to be not that much easy to solve it. So while you are following the basic steps, it will be easy. Try to follow the procedure while you are solving the problem. Try to find a shortcut method to find it. Okay, another simple technique I am going to say before ending my course lecture now. I am going to have a voltage source. If I have a resistance parallel across it, just leave this resistance. It don't have effect. Similarly, if you have a current source, just a series with it and a resistance, they don't have an effect. So we can neglect it. So these are the Thevenin's theorem we say. Again, I am repeating a Thevenin's theorem. A Thevenin's theorem is a linear bilateral network which can be converted into a single voltage source and a a single voltage source and a resistance. That resistance is called as a Thevenin resistance or look back resistance. The voltage source is called open circuit voltage. Thank you. Let us see in the next section.